Hello everyone, my name is Kadu and today I am here to explain you about my project based on machine learning using Python, which is taught by Skyfi Labs and it is an online course. I will start with the basic information regarding I will start with some basics of machine learning. First of all, I want to tell you what is a learning. Learning in the context of machine is the ability of machine to perform the task without explicitly programmed to do so. For example, a self-driving car. The machine has not been explicitly programmed to handle every possible scenario while on road, but it will learn by its own. In traditional programming paradigm, we have to give input to a program, and by that we get the output. But in machine learning, the input and output is provided to a model so that the model performs and learns by itself and gives the necessary arrangement or the predictions. Uh, the formal definition of a machine learning says that a computer program is said to learn from experience E with respect to some class of task T and performance measure P of its performance at task in T as experienced by P improves with experience E. There are three types of learning. First is supervised learning, second is reinforced learning, third is unsupervised learning. Supervised learning is defined as the in which the machine is being told to learn giving inputs and the expected output. Then it is called as supervised learning. In unsupervised, if the machine if the machine is learning to differentiate different input without any information on what they are, that is without any label, is called as unsupervised learning. Third is reinforced learning. If the machine is learning to perform tasks by trial and error where each successful try results in reward and wrong try results in punishment, is called as reinforcement learning. In our project, which is regarding the prediction of Boston house pricing, we'll use supervised learning. In supervised learning, input and output pairs are given and it is a task driven. In unsupervised, only inputs are given and it is a data driven. And reinforced, input and performance are given to as a set of format of data and it learns by reward punish drive. There are three categories of output. The outputs that will be getting from that will be used to feed to a model, and they are classified in three types. First is regression, second is classification, third is clustering. I will tell you about regression. Some commonly used regression methods are linear regression, logistic regression, and polynomial regression. Regression is a simple and well understood technique, but the real world applications are limited compared to other techniques. Classification. It is the technique of giving correct label object from a set of possible labels. Classification is used to classify images. Clustering. It is a technique where sample from the data is placed in a cluster such that all the samples in the cluster are similar to each other. Some key terms that are used in machine learning are features, target or labels, models, training, prediction. Features are the set of values that define the properties of the data sample. Target is the expected output for the given set of features which will be given by a model that we will be training. A model is a hypothesis that defines the relationship between feature and the target. Training, the process where model use the data set to learn to predict the output is called as training. We have to divide the data in three types. I will tell you further about that, but we have to divide it into three types. So we will start with our project. So the Boston house database, we have to predict the prices of house in Boston area. I will describe you the problem. Uh, we have to predict the price of house. Model has to look at data and learn relationship and features. We will use the Boston house data set for the purpose. The Boston house price dataset consists of prices of the house of Boston. It consists of 506 data points where each data point has a price value and 13 features. We can see those features here. It is already showing that number of instances is equal to 506 and number of attributes is 13. We can see these 13 attributes right here. So for our convenience, and we have to load all the necessary data for our Boston house. We have to import some libraries from outside like numpy, and we will be giving as np as its alias. We have to import as pandas. NumPy is used to handle multi-dimensional array. It provides an easy way to perform vectorized operation. Vectorized operation is an operation on vectorized data type. We have to import pandas as pd alias. Pandas provide easy to use data structure for the data analysis. We'll use pandas to load the data into the data frame. Similarly, we will import matplotlib and will be giving alias mpl. Matplotlib basically is used to draw a graph. We will import matplotlib byplot as plt. This function is used to provide animation in the program. From these all are imported from sklearn library. Sklearn library is a free software machine learning library for Python programming language. It provides many algorithms out of the box. It also provides modules for many common tasks in ML, such as loading datasets, splitting the datasets, pre-processing, model evaluation. So first we will require we have to follow 5 steps to achieve the machine learning technique, and those 5 steps involved in problem with machine learning are data pre-processing, data second is data defining, third is split the data into two parts, training data and testing data, fourth is train model, we will be training model to perform, fifth is the prediction, which is our last step. So this is the first step in which we are importing the Boston data, Boston house dataset. It is an inbuilt dataset which is provided by sklearn libraries. So for the description of Boston house, we have used Boston is equal to load Boston function, and we have printed the Boston description by using DESCR as the abbreviation. So first, for the visualization, the pandas data frame object provides a method called describe. As the name of the function indicates, this function provides a statistical description of dataset. So we have used this describe function here. So visualization, Description is usually the first step that we must be take after importing the data to gather basic insights regarding the data variable and also understand the overview of the description. We have to find the correlation between the between the target and strongly paired variable so that how they relate to each other very well. Correlation is a statistical technique that can show whether and how strongly pairs of variable are related. So for the we have shown our we have put the data into pandas data frame using we have printed all the features. You can see this features here and there's values inside them. For testing we have also shown the feature as age here, and we have also shown the data frame of target. This is the data frame of target. Maximum value of target is also we have shown here. Minimum value of the target is also shown. We have concatenated the feature and target into single data frame so that it gives an ease to see how we have to go forward. We also rounded off the decimal to place 2. We have also this in this piece of code we have tried to find the correlation with the with with the target variable. So we have plotted the bar graph related to it, and we have named that as the attribute and correlation with the target variable. We have calculated the correlation from this piece of code. You can see that LSET has the highest correlation with the target variable, so we will be using one of our feature as LSTAT, and we have defined it as a X data frame and Y data frame is labeled as target. So we have to perform normalization in pre-processing. The goal of normalization of the data is to change the value such that after the transformation all the values lie in same common scale. In our case it will be between 0 to 1. Okay, so before normalization, as you can say, it is 24, 21.6, 34.7, which is very huge, we can say. So we will be using scalar method to do that. A scalar provides a min-max scalar that takes a list of values on any arbitrary range to gives a list in which the value are in range from 0 to 1. So we have used that scalar method, and after the normalization we have printed y, and you can see that these are less than 1 and these lie between 0 and 1. Now here the pre-processing ends. Now we are at step 2, where we will be defining the error. So I will tell you about loss function. Loss function is a function to measure how well the model fits into the data set. There are three types of loss function. Mean square error. First is mean square error, second is mean absolute error, third is cross entropy error. We will be using mean square error. So I will tell you about what is mean square error. Mean square error is used as a loss function when target attribute is continuous data. Second, I will tell you about the mean absolute error. The average of sum of absolute differences between the prediction and actual values are called as mean absolute error function. Cost and entropy. Third error loss function is cross entropy loss. The value of this loss function is increases as predicted probability diverges from the actual value. Measure of performance classification. It is mostly used in classification model, so we are not going to use it. So here the step 2 begins. In this we will generate some sample data which will be value of the sine wave. Okay, I can show you right here. See, as an example we have shown that this sine wave which shows us, and we have also added noise to it so that we can see how it performs in noise as well. The three functions that constitute the model are error, update, and gradient descent. We will learn, I will tell you further about this. But first we will be defining the error. We have defined the error here, and update function here, and gradient descent here. Splitting, I will tell you about splitting of data. The splitting of the data occurs in 3 steps. There the data is divided into 3 categories, and first is training data type, data set, in which 65% of through which this model learns mostly about the what he has to perform. Second is the validation data, in which the fitted model is used to make prediction based on the second data set called as validation. The validation data set provides an unbiased evaluation of model fit on the training data set while tuning the model. Okay. Lastly, it is shown to the real world data set, that is test data set. It is a data set used to provide, sorry, it is not shown to world, but world data, but it is used, but it is tested with test data set. It is a data set used to provide unbiased evaluation of final model fit on the training data set. Training dataset is 65% of the whole data, validation is 15% of the whole data, and testing is 20% of the whole data. Our third step is splitting of the data. So here we have 0.2% indicates that we have splitted the rest of the 20% as the testing data, and through which we will be splitting the data. sklearn provides a function called train.test.split to split the data. The parameter to this function are the dataset and fraction dataset to be considered for the testing dataset. Now we will be performing linear regression. Linear regression takes its origin. Linear regression takes its origin from statistic. It is a method to understand relationship between input and output numerical value. For linear regression, we have to perform a gradient descent algorithm to minimize and function. A gradient descent function is implemented with 3 functions. First is the error function, then update function, and third is gradient descent function. In update function, the purpose is to update the weights such that the weight get closer to the final values. In error function, the purpose is to calculate the cost function at the current position. Cost function is nothing but the mean squared error. A gradient descent algorithm is a function used to implement the gradient descent algorithm with the help of two functions that we have already defined earlier, that is error function and update function. Okay, so for the visualization of data, matplotlib provides a class called funcAnimation to generate the animation of the graph. We will use this we have used this class to generate the animation of the regression line changing from initial position to final position. So you can see that animation right here. Look, this is the final position of the line, and look, it starts from right here and it turns clockwise. For this we have to define the init and update frame to use this. The init function is to initialize the graph, draw the training data such that it is in the background, and set the limit of x and y axis. It takes no parameters, but it must return the function linef. Okay. Update frame, the purpose is to set the data from next updated frame. In our case, we will use this function to extract next slope m and intercept c values from the array of mc values and compute the coordinates. So as you can see, we have performed all the, we have also plotted the regression curve here, and we have also plotted the error. As you can see, the error is comes parallel to the x-axis, which is a good thing for us. Now this was our fourth step, which involves the splitting of data into training set, validation set, and testing set. Okay, so we will come to our last and final step of prediction of values. First, we have to compute the predicted values for each x values using the line equation with the m and c values learned from the gradient descents, which we have already found. We have to reshape the predicted x test and y test and arrange them in a row to a column so that it is easy for us to show. We have to scale the predicted x test and y test and arrange and store them as a predicted scale values in a data frame. The scaling adds an entire dimension to each of the arrays. Therefore, we have to remove it with an slicing operation. So we have to find we have calculated the prediction on the test as the vertical operation by this code. We have also computed the MSE of the predicted value, and we have put it both x test, y test, and predicted value in a single frame so that we can see the predicted values alongside with the data set. You can see that right here. This is the x data set. It is the target value, target y, and predicted. You can see here we are very much more closer. Target y and predicted is much more closer to each other. We also plotted it using plt.plot, which we have already used earlier, which is provided by matplotlib. So after all this, we have to reshape to the predicted data. So for reshaping, we have used dot reshape function, and we have reshaped y test, x test by from -1 -1 1 and x test, and we have also scaled them by using scalar dot inverse transformation. Inverse transformation adds an extra dimension to the array, so we have to remove the extra dimension, for which we have performed this piece of code. We have also put that in a data frame, and we have also printed it. So as you can see, the predicted value, the target value y and predicted y are quite similar. There's some difference, but it is quite similar, so that we can say that our uh, project was successful and it is giving the prediction very well. Thank you from my side. That's all.